Cioxfer is a technological spin-off of IMCS Group, dedicated to bring added value to the development, implementation and integration of technological projects, offering products based on effectiveness, competitiveness and profitability standards. We have designed a set of products to open IBM mainframe architecture, by offering solutions that allow the collaboration, execution and expansion of mainframe processes anywhere, anytime and in any language with the corresponding optimization and reduction of mainframe costs and system infrastructure. Servers are great. They allow us to run applications to do business. However, to ensure the execution of an application, we usually have to use more than one server by application. This is not only as a measure of protection against failure of the server, but also for scalability, if the application is used by more users than expected, as it is often the case when the application is servicing Internet, instead of a fixed set of users inside a company, where capacity planning is easier. But the organization by servers or clusters does not solve at least three main issues. 1. A lot of processing power is not used, 30 to 50% or more even. 2. If the servers assigned to an application fail, the other servers, usually, cannot be used to run the orphan application. 3. Load balancing is usually defined at setup time and cannot be easily adjusted dynamically or automatically, taking advantage of other servers' remaining capacity. Organizing application by servers is not the best way to maximize the performance, the reliability and the use of all the available processing resources, or at least, it involves a lot of monitoring with many people and resources. Scientific calculation is known to use a lot of processing resources, and has led to the design of centralized very expensive supercomputers, called HPC, high-performance computing, with teraflops and now petaflops of calculation capacity. The ranking of supercomputers is changing every year as new contenders for the title of fastest and biggest enter and make the anterior look obsolete. Next limit is exaflop calculation capacity for 2020. While these supercomputers were being designed and built, in the late 90s, a concept of distributed processing was born to create a virtual supercomputer by using many networked loosely coupled computers, mainly on the Internet but not exclusively, acting together to perform very large tasks. This was called a grid, referring to the idea of computing being a resource like electricity, power grid, that can be used by plugging in the computing network. An example of grid used for scientific purposes is the SETI at Home project, that started the BOINC grid platform that is now used by many scientific institutions, like the ATLAS experiments at CERN responsible for the discovery of the Higgs boson. The BOINC platform is based on a screensaver that was built for the SETI at Home project and uses CPU idle time of a PC that normally shows a screensaver. Instead of moving bubbles or presenting a slideshow of pictures, the BOINC software uses the PC to execute one of the projects the user has accepted to donate computing power to, and works on the data received. Whenever the users need to use their computer, the screensaver stops, saves the current calculation up to this point and control is given back to the user. When the calculation is finished, results are sent back to the owner of the project and may work on more data. Although it has proved and is still proving to be a very successful technology, until now existing grid platforms have not been used in traditional business environments. There are several reasons to explain why it has not been done, but a few of them are: 1. Grid processing is very successful when problems can be solved using parallel algorithms so that a big problem can be cut in small pieces that can be processed simultaneously on different processors, and collate the results. 2. Business processes usually are not solved with parallel algorithms but are sequentially programmed, making it difficult to be used on parallel computers, either HPCs or grids. 3. Parallel programming is more difficult to design, manage and debug than sequential programming. It has the advantage, however, to shorten the duration of a process if there are enough available processors to distribute work on each of them. 4. To be able to use HPCs or traditional grids, business processes would have to be rewritten and adapted to the interface that they use, something not realistic for all the legacy business existing software. 5. Data transfer is also an important factor as each processor has to receive all the data needed to work and send the result back. Both HPCs and grids work better on small input, small output, big calculations models than any other combination. An example of it is the SETI at Home project calculations, where the data input is a small chunk of radio data. Calculations are intensive and SETI results are like, yes, there is a possible artificial wave emission in this piece of data, or, no, nothing noteworthy here. On the contrary, business processes usually tend to be much more input-output intensive than calculation intensive, and do not use complex floating point operations like fast Fourier transform, or similar. Clouds and grids may seem to be the same, but they are different and rather complementary. Clouds are a convenient way to provision and manage computer resources, servers, storage, or even services, offering self-service provisioning, elasticity, pay-per-use, workload resilience, migration flexibility. Grids manage the resources of the servers they are running on, to provide services and guarantee their execution even in case of failure of a server. Grids need servers to implement their services. Clouds are a great way to provision servers and run on them, but they do not need clouds and may run on ordinary distributed servers provisioned in other ways, like in the case of BOINC users that attach themselves to the grid and provision their PC voluntarily. Alba is the next generation of grids able to work transparently with any set of processes, scientific or business, without having to redesign and rewrite any of them, to adapt it to grid technology. Alba is still able to maintain the original grid benefits of high scalability, high availability, fault tolerance, running on heterogeneous systems, load balancing, self-healing. The resulting platform, Alba, is the fruit of more than 15 years of R&D and operational use in business production systems. See our next video on how Alba works.